So here we have, if we look at the term on the left hand side, this is the vector, this is the scalar product of four vectors, although A here is repeated. So we will use the formula that if we have A cross B dotted with C cross D, this can be expressed using a 2 by 2 determinant, which can be remembered if we distribute A cross B with C cross D as A. This will be, in the first row we have A dotted with C, then we have A vector dotted to D vector. In the second row we have B vector dotted with C and B vector dotted with D vector. So we will use the same form to prove this particular relation. So let's start with A vector cross B vector dotted with A vector cross C vector. So this will be equals to, so we'll consider this 2 by 2 determinant. In the first row we have A vector dotted to A vector, so that's simply A squared. Then we have A vector dotted with C vector. And in the second row we have B vector dotted to A vector. So B vector dotted to A vector is the same as A vector dotted to B vector, because the scalar product always commutes. And we have B vector dotted to C vector. Now, if we expand this determinant, all we have is A squared multiplied to B vector dot C vector minus, so we have A vector dot B vector. So this will be multiplied to A vector dot C vector. This is proof. So this is a very simple proof. All we have to remember how to write this particular determinant.